Okay, see Lindelof videos, solving logarithmic functions, part 2. In this video, what we're going to do is actually use some of the property of rules of logarithms to solve this. So here we are with this. This looks horrible, but the good news is it's going to clean up really nicely. Remember that there's a rule that says if we have same base, so log base 6, same bases, and there's a minus sign separating them, then what we really have is log, whoa, I'm going to get rid of that, it's too big. Is we have log base 6, we have log base 6 of x plus 1 over x. And this is based on laws of exponents. I'm not going to argue right now because I made tons of videos about this. But if you have these two same base logs separated by a negative sign, you divide the first argument by the second argument, keeping the log here the same. So that gives us log base 6 of 29. Because both terms, the left term here and the right term here, there are no terms added to it, and they have the same log. They have the same log base. We can drop the log bases. They don't cancel. We just drop them because the argument is the only thing we have to prove because they're of the same thing. This has to equal this. So it makes pretty good sense to me. So what we're going to do is take this argument here, x plus 1 over x is equal to 29. And 29 over 1, isn't it? This actually gets really easy. We're just going to use the means extremes theorem, and we're going to cross multiply. Means extremes theorem sounds good, doesn't it? 1 times x plus 1, well, frankly, is x plus 1. And x times 29 is 29x. True or true? Of course. So to solve this just algebraically, minus x from both sides, because we want to get the variables isolated to one side, 1 is equal to 28. Sorry, I can do this. Is equal to 28x. Wow. Is equal to 28x. Well, how do you separate this? We're trying to solve for x. Divide by 28. Obviously, algebra 1. Divide by 28. And x equals 1 over 28. This is your answer. I think it's not so bad. It's not as bad as we think it is. Keeping in mind, you have to know these rules that I'm talking about. And I'm not being a smartest, but if you don't know those rules, go back and get them and memorize them because that's what's happening in class. You're like, why do they keep doing that? They're applying these rules of exponents. Excuse me. Last problem. This is a similar thing. We have ln, and ln. Remember, ln is log base e. So I'm not going to convert to that, but we have this. This plus sign right here tells me that we're going to multiply these two arguments. So we have ln of 2x minus 3 times x plus 4 is equal to ln of this junk on this side. Good? Right? So, right? This plus sign told me to multiply. So I'm going to go ahead and multiply that out. When I multiply that out, I get ln of, I'm just doing FOIL here, so just to be clear, 2x squared plus 5x minus 12 is equal to ln 2x squared plus 11. Again, doing the same thing we talked about before. I have everything down to ln of an argument, ln of an argument. ln is the same log and base as ln, obviously, so I can drop them because all I have to do is make the arguments equal to one another. So this is what I'm going to get to now. So I'm going to get 2x squared plus 5x minus 12. This looks like algebra 1 or 2, doesn't it? Equals 2x squared plus 11. I think that I'm going to move all the variables to the left-hand side. You can move them any way you want. It won't change a thing. So 2 minus 2x squared here, minus 2x squared here, leaves us with 5x minus 12 is equal to 11. How am I doing? I agree. Going to just keep doing my algebra. So I'm going to add 12 to both sides. 12 to both sides. I get 5x is equal to 23. Last thing I'm going to do is divide both sides by 5. That's a 5, I swear it is. 5 divided by 5 is 1, leaving us with x. 23 divided by 5, right? This is intermediate algebra, so we don't have to simplify this crap into a mixed number. So there's our answer. And the answer I get was 23/5. If you're wondering where I got these problems, I got them from Kudasoff Algebra 2, solving logarithmic equations. So I hope this is helpful. If you have any questions, comments, please let me know. And if you haven't already subscribed, please do. I appreciate it.